All right, welcome geometry students to beautiful Foz do Iguaçu in Brazil. And I'm going to be talking to you today about finding the area of a triangle. And I want to find the area, I need to find the base and the height. Our base and our height would be, if I'm going to set this triangle down, we can think of the base as the bottom and the height as how tall it is, right? Okay, in this case, if I just reorient the triangle this way, you can see it's a right triangle. Now, why is that important? Because a right triangle, since we already have a right angle, we can identify both our base and our height from the sides of the right triangle. And then we can simply do what? Base times height divided by 2, or 1/2 base times height, which is the formula we know for the area of a triangle. Okay, now if I took another triangle the same size and I put them together, you should be able to see that that would give me a rectangle, right? And we know the rectangle is just the base times the height. And then I divide it by 2. Voila, there's the area of my triangle. Well, how am I going to find the area of a triangle, a right triangle on a coordinate plane? I can simply count the 1, 2, 3, 4, 5. Let's call that our height. And 1, 2, 3, 4, 5, 6, 7, 8. Let's call that our base. 5 times 8 is 40. What's the area of this triangle? Not 40, it's 1/2 of that, so it's 20 square units. Super easy. So let's start out with a problem. And let me say it's very important you do these problems with me so that you're able to do them on your own later. Take your graphing paper, and I want you to plot these 3 points. So you can pause the video right now. Plot point A at 6, 8, B at 6, -2, and C at -4, 5. And let's just use a scale of 1 for our x-axis and a scale of 1 for our y-axis. Here should look very similar to this. If we want to find the area of this triangle, we have to find the base and the height. Now, we can use any of the 3 sides for our base, but notice AB is a vertical line, which means that the perpendicular to AB is simply a horizontal line. Where do we want our perpendicular line to go? We want it to go to our vertex. I think you can see that we could simply draw it right there. And so go ahead, pause the video, and draw a horizontal line between the vertex C and the base AB. Did you draw something like this? I made my line segment as a dashed line segment. That's common practice in math to show this, but it's simply marking the height of our triangle. The orientation isn't real important, so I could just turn it like this, and then you can clearly see that this is my base and this is my height. You're going to always look for that right angle when you want to find your base and your height. They must be perpendicular to each other. Your base will always be one of the sides of the triangle. So now we have enough information to calculate the area of this triangle. Go ahead and see if you can do it yourself. If you did it correctly, you should have got an answer of 50 square units. If you got 100 square units, you probably forgot to multiply by 1/2. So I just simply counted my base since it was 10 units long, and my height was 10 units long. 10 times 10 is 100, and 1/2 of that is 50 units squared. Anytime we're doing area, we're talking about 2 dimensions. All right, so let's go ahead and try a problem that doesn't have a horizontal or vertical line, and that will require us to use slope in order to find the area of that triangle. All right, so again, do the problem with me. Go ahead at this point and pause the video. Plot these 3 points on a coordinate plane with an x scale of 1 and a y scale of 1. Use a straight edge to connect the 3 points and make triangle A, B, C. All right, did you get a triangle that looks something like this? So we don't have any right angles. It's not a right triangle. How are we going to find the height? We could use any of the 3 sides. In general, you want to use the one with the simplest slope. So here are a couple of lines. Notice if I put two boxes on top of each other, that makes one diagonal. So we say that this line has a slope of 2. Vertical 2 over horizontal 1. Over here, up 1 and over 2, right? So 1 over 2 for a slope of 1/2. I've gone ahead and marked these ones. Can you see what the slope would be? A slope of 3, but in this case, because left to right, it's going down, we would say this has a slope of -3. From left to right, it's going up to down, so it's also going to be a negative slope. Did you figure out what it is? If you said -1/4 or 1 over 4, you were correct. Why is this important? Because perpendicular lines have slopes that are opposite reciprocal. All right, so on our triangle, we're going to use CB as our base because it has a really simple slope. Can you tell what it is? Did you get a slope of -1/2? If you did, you're correct. If we have a slope of -1/2, the opposite reciprocal slope would be a slope of 2. So we want a slope of 2. And where do we want that line to begin? We want that line to begin at the opposite vertex, which in this case is A. I'm going to start at A, and then I'm going to, if I take these two boxes right here, right, these two boxes, my next point would be right there, my next point here, my next point here, and then another point there. This represents my height. It's at a right angle. Okay, how do we know that? This slope is -1/2, and this slope is +2, opposite reciprocals. And so let's call this our base down here. How are we going to find the length of the base and the length of the height? We can simply do what? Distance between points formula, or better yet, Pythagorean theorem. At this point, go ahead, pause the video. Let's see if we can find the length of our base first. So if you got 6 times the square root of 5 units, give yourselves a pat on the back. If you got square root of 180, you got the correct answer, you just didn't simplify it. All right, how did I get that answer? So I drew a horizontal and vertical line to make a right triangle, 6 units by 12 units. And then I simply do the math, right? V equals 6 squared plus 12 squared, which gives me the square root of 180. 180 is divisible by 36, which is a perfect square. So it's actually 36 times 5. That gives me square root of 36 times the square root of 5, or simply 6 times the square root of 5 units. And then you should be able to use Pythagorean theorem to find out the height. Don't forget to simplify your answer. Did you get 4 times the square root of 5 units? Don't be ashamed to pause the video and make sure that you understand the math. So let's summarize what we know. We know that the base is 6 times the square root of 5 units, and the height is 4 times the square root of 5 units. So can we go ahead and find the area of this triangle? The area is 1/2 base times the height. So square root of 5 times square root of 5 is 5. 6 times 4 is 24, and half of that is simply 12. So to find the area of this triangle, we simply do 12 times 5, or 60 units squared. Okay, so remember to comment down below for an easy free grade just for watching this video. And look tomorrow on miller.mathevolution.com to find your assignment. All right, everybody stay safe. Hasta la vista, baby.